Dear friends, this video talks about robot drive system. In particular, the various types of robot drive system and comparison of their characteristics. I am Dr.R. Professor, Department of Mechanical Engineering, RVS College of Engineering, Dindigul. Robot drive systems and their functions. In the previous videos we already discussed a robot is a linked arm and the links are connected together by means of joints, and these joints are going to move, so we have to provide necessary force or power to move the joints. So the drives are connected with these joints to move the joints. So the drives are connected to the joints for the movement of the joints. By that, the manipulator is going to do the necessary work. So the purpose of the drive system is to drive the mechanical links of the manipulator to a desired position and orientation in the work envelope. So this is done by means of power drive in the joints. There are other transmitting devices like gears, belts, cables are also used to achieve this. Sometimes the drives are going to be direct drives. The drives are not direct drives, then some power transmitting devices are required to transmit the power to the joint. So the drives are classified as hydraulic drives, pneumatic drives and electrical drives. So the drives are chosen based on various factors such as power consumption, the positional accuracy required, speed of operation, reliability, cost and many other related factors. So first one, we are going to discuss about the hydraulic drives. So the hydraulic drive, the final actuator is going to be a linear actuator or a rotary actuator. So in mechanical systems, any kind of mechanical systems, we need two types of motions, either a linear motion or a rotary motion. So we need a linear drive or a rotary drive. So in hydraulic system, we are using two kinds of drives. One is called as linear actuators or linear drives, that is called as double acting cylinders, and a rotary actuation that is achieved by the hydraulic motors. So how the power is supplied to the actuators, that is given by a hydraulic system. So in a hydraulic system, there is a pump which is driven by an electrical motor which supplies the pressurized oil to the system. Then this pressurized oil passes through various valves and finally it reaches to the actuator. As I already mentioned, there are two kinds of actuator, either a linear actuator or a rotary actuator. So in this system, this is a simple hydraulic system you can see here. So there is a reservoir. So from the reservoir, the oil is passing to the filter and filter to the pump, and the pressurized oil is going to the valve. That is, this is actually called as a direction control valve. So from that, actually it is going to the double acting cylinder. So by this, the cylinder is going to reciprocate. So instead of a cylinder, if you are using a hydraulic motor, you are getting a rotary motion. There are some more valves are also present. This is a direction control valve. There are some more valves are also present. One is called as pressure control valve and another one is called as flow control valve. So there are various kinds of pressure control valves are used to adjust the pressure in the system. And another one is the flow control valve, which is used for controlling the amount of fluid flow going into the actuator. So the hydraulic drive system, what are the various applications we can see here from the diagram. One is the hydraulic robo, which is operated by rotary actuators, that is by hydraulic motors. In another case, it is going to be linear actuators. You can see a cylinder here. This is a linear actuator. So hydraulic robos may have the hydraulic motors or otherwise the hydraulic cylinders, and the basic system what we explained earlier. So what are the advantages of hydraulic drives? So hydraulic drives are generally used for increased payload, because the pressure what we can develop by using a hydraulic system is enormous. So the force we can obtain from the hydraulic drive is larger. So because of that, we can use it for larger payload capacity robos. Second one, it can take heavy loads yet provide a very smooth operation. Because it's an hydraulic oil, it can provide a very smooth operation. But there are some limitations are also there. So the limitations are, even though we are providing better seals and other things, there is always some leakage in the hydraulic system. So the leakage of oil is cannot be prevented in the hydraulic drives. And second one is, because of the inertia of the oil cannot be accelerated so quickly. So the hydraulic system is slow in operation, or it is sluggish in operation. The reason is the inertia of the oil. The next drive is called as pneumatic drives. The pneumatic drives use compressed air for driving the actuators. So here the basic element is, air is sucked into the compressor, getting compressed. The pressurized air or compressed air is passing through a primary air treatment process. The primary air treatment is going to be an aftercooler, a filter, then a dryer. So all these things are called as the primary air treatment elements. So after the primary air treatment, because it is cool, then the moisture in the air is removed, that is called as the dryer. Then it is stored in a reservoir or a receiver. Then from the receiver, it goes to the main ring or ring main. Then it is going for the secondary air treatment. The secondary air treatment, we are having three elements called as filter, regulator, lubricator. Simply it is called as FRL unit, the trial unit. After passing through the FRL unit, the filter filters the dust particles. Then the regulator regulates the air pressure. The lubricator adds some quantity of oil in the air as a mist to lubricate the moving parts. So after passing through the secondary air treatment, it is going through the control valves. As I already mentioned earlier, the flow control valves as well as direction control valves, and finally it reaches the actuator. Again, in the pneumatics, there are two kinds of actuators. One is the linear actuator, another one is the rotary actuator. Linear actuators are called as cylinders and rotary actuators are called as pneumatic motors. So this is a robo which is operated by Pneumatics, a very popular company called Festo. They are the pioneer in the pneumatics. So this robo is operated by Pneumatics. So the air is supplied to the robo and the pneumatic drives are used for operating the robo. So again, the advantages of pneumatic drives, if you are considering the pneumatic drives, they are very simple in construction and less expensive than hydraulic system, because when considering the pressure in the pneumatic system, the pressure is limited to nearly about 10 to 20 bars. The reason is because the compressibility of air is limited and air cannot be compressed more, so the size of the compressor is going to be limited, and because of that the pressure increased is nearly about 10 to 20 bar, and by that actually the force given by the pneumatic system is going to be less. So we don't need very high strength materials for the construction of the pneumatic components. So because of that, the pneumatic drives are simple in constructions, and very important thing is in hydraulic systems the oil has to be returned back to the tank. So the return line is very, very important in the case of hydraulic system, but in the pneumatics there is no return lines. The air is let it to the atmosphere or exhausted to the atmosphere. By that there is no return line. So when we are comparing with the hydraulic system, the pneumatic systems are simple in construction. And as air is a lightweight substance, it can be easily accelerated and decelerated. When we are comparing with oil, the air is having low inertia, so by that it can be easily accelerated and decelerated. And moreover, because of the compressibility of air, because oil are incompressible fluids and air is compressible fluid, so because of that the compressibility of air which helps in absorbing the shock also. But the limitations are also there. So the limitations, as I already mentioned, the pressure limitations are there in the case of pneumatic system. We can't go beyond 10 to 20 bars. So because of that, it can provide only low force or low power. So the pneumatic drives are used in low power applications. Second one is precise control of velocity and position in pneumatic system is rather difficult, as the arm of the pneumatically driven robot will sag and reduce the repeatability of the robot. Because we are having the compressibility problem, there is a phenomena called a stick-slip phenomena, and due to that we can't control the velocity and position very precisely in the pneumatic actuators. That is reflected in the robot, and the robot will sag and it won't provide better repeatability when we are comparing with the hydraulic system. So the accuracy and repeatability can be increased. It is possible when you are using servo systems in the pneumatics. So you can use servo systems in the pneumatics as well as in the hydraulics, but they are expensive. The third type of drive systems, the electrical drive system, which is very common drive systems in the robotics. This is becoming more and more choice of drives in design of the robots. The very reason is it is having excellent controllability with minimum maintenance required. So electrical drive systems have excellent controllability that is possible with electrical drives. The controllability is so good, so because of that they are much used in the robot drives. The common electrical drives are stepper motors, servos. The servos can be classified as DC servos as well as AC servos. So again, if you go for a very precise control, if you want better repeatability, obviously in the hydraulic system and the pneumatic systems, we can use the servo systems. There also we can use servo systems, closed loop systems, but those systems are very expensive when we are comparing with the electrical drive systems. In electrical drive systems, electrical amplifiers or other electrical control circuits that can be used which to provide a better controllability, but the system is going to be less expensive when we are comparing with the hydraulic or pneumatic servo systems. So electrical servo systems are cheaper than hydraulic or pneumatic servo systems. So by that actually we can get very good controllability, and because of that the electrical drives exhibit good repeatability. So this is again an electrical operated robot. You can see various motors are present, a base motor, a shoulder motor, elbow. This is wrist motor. So all these motors provide rotary drive. In common, electrical drive systems are rotary drives, but nowadays linear drives have been developed. So when they are rotary drives, if you want the motion to be converted into a linear motion, the proper conversion of the linear mechanisms of, that is the rotary to linear conversion mechanisms are used for converting the rotary motion into linear motion. So here you can see two kinds of robots. This is again an electrically operated robot, but the drive used is stepper motor. Normally this is open loop drive systems. This is stepper motor. The second one, what we have seen is the servo motor drive. So this is for closed loop applications. So we are using actually servo motors. So when we are comparing the various drive systems, we are going to consider the various characteristics or aspects: hydraulic drives, pneumatic drives and electrical drives. The first one is reliability of the components. So the hydraulic drives, the reliability is low, the pneumatic, the reliability is higher, and the electrical, it is high. So the pneumatic is having the highest reliability. We are considering the accuracy and response. The hydraulic drives have very good accuracy, and second, on the pneumatic it is bad because of the compressibility problem, and third, the electrical system, it is having the higher accuracy and response. We are considering the torque and force of the actuator. Obviously, the hydraulic system is having very high torque and force because the hydraulic system develops a lot of pressure, and this pressure is converted into the force or torque. So a high force or high torque can be achieved in the hydraulic system. So that is why the torque and force of the actuator is high here. Pneumatic, the pressure is limited, so because of that it is only low to medium. And the electric, it is medium to high. So we can place electric in the middle. So pneumatic is low, electric is medium, and hydraulic is high. So the torque developed or force developed by an electrical drive is lesser than the hydraulic drive systems, but it is better than the pneumatic drive systems. Range on operational speeds. The hydraulic drives is having very wide operational speeds, but it is limited in the pneumatic system, very little, and it is comparatively less. So the electrical drive system is also having less operational speed range. And power to weight ratio. What does it mean actually, the power to weight ratio? The size of the system and the power developed by the system. That is what we are calling it, or the weight of the system and the power developed by the system. That is what actually called as power to weight ratio. So how much power it is going to develop and what is its weight. So the ratio between the power developed and the weight of the system, that is what we are calling it as the power to weight ratio. So when we are comparing, the hydraulic drive system is having the highest power to weight ratio. This is what we already mentioned. Though the pressure developed is larger in the case of hydraulic system, accordingly the system is not going to be very big, or it is not going to be voluminous, or it is not going to have more weight. So though the pressure developed is higher, the pump is going to be, even a very small pump can develop a high pressure. So by that the system is going to be not voluminous, or it is not having more weight. So the power to weight ratio in the hydraulic system is having is highest actually. In pneumatic it is lowest, and electric it is moderate. So the electrical system, the power to weight ratio, obviously when we are increasing the power, the weight of the electric system is going to increase. The reason is the power developed by an electrical drive is depending upon the iron content of the drive system. That means the amount of coil present in the electrical drive system decides the output EMF or the power. So in that case, if you want to have more power, you have to add more coil or more iron content. That means the weight of the drive is going to increase. So if you want to increase the torque or power, then obviously you have to increase the size of the motor, or which we can call it as the weight of the motor. So the electrical drive systems are having a moderate power to weight ratio. And leakage and cleanliness, this aspect is only related to hydraulic. It is going to be worse. Pneumatics also there may be leakages, but it's better. Okay, but electrical system there is no leakage at all. So this aspect is not related to electrical drive systems. And next one is size and stiffness. The hydraulic stiffness, the size is going to be small in the case of hydraulic drive system, but the stiffness is going to be very high. Here the stiffness is going to be very low, and it is having low stiffness. So the stiffness factor, if you are considering, the hydraulic is having very high stiffness when we are comparing with the pneumatic as well as the electrical drive systems. So compliance of the system, the compliance is low in the case of hydraulic. In the pneumatic it is going to be good, in the electrical it is going to be better. So the compliance is low in the case of hydraulic system, and pneumatic is good and electrical it is better. And maintenance, hydraulic system requires more maintenance, pneumatic systems require less maintenance, and electrical systems need very low maintenance. And payload carried by the robo, obviously the force that can provide by the hydraulic systems is more, then it is having highest payload carrying capacity. In pneumatics it is having the lowest payload carrying capacity, and the electrical lie in between that is it is having a moderate payload carrying capacity. So this is about the various types of drive systems used in robotics: hydraulics, hydraulic drives, pneumatic drives, and the electrical drives, and the comparison of these three drive systems. So if you want a heavy payload and a very accurate speed control, then we can go for a hydraulic drive. If you want more accuracy, repeatability, controllability, then the choice is going to be the electrical drive. If you want a low payload capacity, and if you want the system should be very quicker, then the choice is going to be the pneumatic drive systems. So with this, I will conclude this video. Thank you.